I'm Zsófia Kocsis from the HungaroMet service. I have been working satellite data since 2008, and many of you might have already met me during weather briefings. So let's see first what was happening this morning in Europe. So I have put here the 24 microphysics RGB from the FCI data, and I like this RGB because we can use it day and night. So in the morning at 6 UTC, if I put here a night microphysics RGB, half of the image would be unusable, and also the sun has not not been there on the western part of this image. So we can nicely see the clouds in this image and have an overview of what is going on. We are able to discriminate between the high thick clouds, which are brownish in the image, and also we are able to see the low-level clouds. I will ask you here, what do you think, which ones are the low-level clouds? You will be able to annotate and put your markers where you think we can see low-level clouds in this image. So you can open your annotation tool and try to mark the low-level clouds. Yes, we have seen one. Can we see any other low-level clouds in this image? No other low-level clouds. Yes, one more. Anywhere else, maybe? Okay, if you are not seeing any more low-level clouds, I will move to the image now, and let's see if you can see any more low-level clouds in this image. I will give you the annotation too, so you will be able to annotate here. So you were marking this cloud here, this low-level cloud. You were marking this cloud here. Can we see any more low-level cloud here? There, yes. Anywhere else? What do you think about these clouds? Do they look like low-level clouds? I think they do look like low-level clouds. We are also seeing some other low-level clouds. Yes, I will just remove the annotation, and in this cloud-based RGB, this is a kind of new RGB with the FCI, which is not so new anymore, but we are also able to see the face of the clouds. We can discriminate between ice clouds and water clouds. So the ice clouds we can see with the cyan color, and we can see the water clouds in different color. As you marked very nicely, the low-level clouds are this yellowish or pinkish clouds. It depends on what kind of particle size we have on the top of the clouds. If we have smaller particles, we will have different color than if we have larger particles. So to see the situation, we not only can see the clouds, as you know, we can also see the different air masses in the air mass RGB. And now, if we look at the air mass RGB, we can see the tropical air mass, the polar air mass. We can see where the atmosphere is drier, the air mass is drier. So I will ask you now if you can maybe, we have looked at 3 different RGBs for the for the same time. So please try to guess where we have low pressure system and where we have high pressure system. You can use your annotation tool to write an age or or an L where we have low and where we have high pressure systems. Okay, we have one L or a low. We have an H for a high, yes. Another low, yes. Very nice. Yes. Good. Very good. Yes. In the next couple of images, I also put on top the ECMWF 500 hectopascal geopotential. So we can see a ridge here. We can see what you basically were telling on the surface, but we can also see it through the atmosphere. Also at the 850 hectopascal, and if we put on the mean sea level pressure, it's easily seen where we have the high and where we have the lows. So very nice. Actually, this is not a very exciting situation over Europe, but as we have tried to see where we have low-level clouds, I also put the SYNOP observations here on the map, and we can see that this verified what we were also seeing on the satellite data, that there were low-level clouds, fog in Britain, and also in the Benelux states, also some not very well seen here, but there were also some in Turkey. Yes, here in Turkey. Oh no, it's Bulgaria, but here in Turkey as well, there were some. And we could also see the precipitation from those clouds. It was also some snow in the morning. And the other thing which was happening during this morning, there were some thunderstorms developing in Northern Africa, moving towards Spain. So here you see the cloud face RGB, and we have established that in the cloud face RGB we can see also particle size on the top of the clouds. So these ice clouds here, and we can discriminate where we have smaller particles on the top of the clouds and where we have larger ice particles. So I will ask you if you can show me in this image where we have smaller ice particles on the top of the clouds, basically on these storms. So you can use your markers again and try to mark the clouds where you have smaller ice particles. Yes. Anywhere else? Okay, I see you are basically marking the particles where the cyan color is not as dark as different places. So yes, those are the smaller particles where we have more intense updraft. So the particles are not able to grow as much as other places. So very nice, thank you. We can also see whether we can have what we can have with the lightning imager. So here we have the accumulated flash area, and you can see that these storms are also having some lightning activity. This shows the accumulated flash area in the last 5 minutes. So let's see what is expected in the next couple of days. So here we have 3 loops showing you the ECMWF forecast from today until the 27th of April. So in the top corner, you see the 500 hectopascal geopotential temperature and wind. We have the 850 hectopascal geopotential temperature and wind, and we have also the mean sea level surface pressure and also the 6-hourly accumulated precipitation in the bottom. So basically what is for me is more striking that there is a polar low developing and getting more to the south east during the next couple of days, causing precipitation, heavy precipitation, probably in some places also some snow and also some wind gusts is expected. That is the most striking, at least for me. And also we can see over this area there is a upper level low coming towards Spain, and this will also cause some thunderstorms in this area. And there is also another low level system moving towards the east in the Mediterranean part, Turkey and the place there with some fronts there. So in the next couple of days, this is what we can expect. So usually in the second part of the weather briefing, we try to cover some of the interesting phenomena which were happening during the last months. So since the last weather briefing, I have put here actually so I have put here images from end of March, 1st of April, with one image every morning. And there is one phenomenon which occurs a couple of times here. If you look through this animation, that you will be able to see some feature appearing several times. So if I move on to the next, to the next slide, you will be able to see the loop again, and also you will be able to annotate and mark which of the phenomena you think we can see several times. So you will be able to mark some of the things we can see. I see some of you have already put dust in there and dips in there. Yes, I also see some, yes, exactly. In the last months, we have seen several times the Saharan dust moving towards Europe and towards the Atlantic, and also some deep clouds were present. I will just stop the annotation, so I will be able to move in during this loop. So as you have already nicely put it there, we have dust here and we have the deep clouds there. I will just stop the annotation, the loop, and here we have a deep cloud, which is dust-induced pyroclinic system, and you are not very well able to see in this loop what we have on the top of the cloud. It looks like it has orange peel on the top. If you try to zoom into your viewer looking at these images, you will see that it looks like the orange peel, or as some people like to say, like cellulite of the skin. It looks like that. So it means it's a little bit looking like some small, very shallow convection is going on the top of the cloud in the morning. Why this is quite interesting, because it does influence the forecast and usually and also how the clouds are behaving. So these are dust-infused bioclinic systems. You can learn more about this in one of the EUMeTrain training modules. There is a very nice training module. So you can learn about how these are forming and also how they look like in the different satellite images. Usually these cloud tops have smaller particles on the top because of all the dust going into the cloud. So this was something happening during April, and also we can see here a very nice dust storm with a front in Africa. We can see how the front has taken up all the dust to the air. And also what is very interesting that we can see these clouds, these waves in the cloud here. I will start again. You can see it here. These are undular bore, called undular bore. And this happens when two different air masses collide. And there is this wave going through. And there is also a very nice training module on different waves in the atmosphere and explaining also what is the undular bores and how it is formed. And basically you need two different air masses to collide to form this wave. And there were kind of several things happening during the last week. So last week I was attending a training course as a trainer, and we were looking at different phenomena happening. And here we have north of Spain, and this is Portugal. And we can see some clouds moving, and we see some interesting phenomena in the image. So my question for you is, what kind of RGB is this? You can use your markers to guess what kind of RGB this is. Is it the true color? Is it the cloud phase, the dust, cloud type, or the fire temperature RGB? I see all of you have already known the fire temperature RGB, which is very good. So yes, indeed, this is the fire temperature RGB, which is very good to observe fires, as we have seen in two places in Spain. Here we have one of the fires, and here we have the other fires. And this RGB actually provides information about the temperature, as it says, of the fire, or the intensity of the fire. It uses the 3.8, the 2.2, and the 1.6 channels. These channels basically give us information about intensity or the temperature or the hotness of the fire. So how this is working? So the hotter the object is, the shorter wavelengths at it emits most. So basically the fires are between 600 and 1800 Kelvin hot. And we can see in this figure that the best wavelengths would be 3.8, 3.9 to observe the fires, because this is closest to the 600 Kelvin peak. But as we move to the hotter fires, we will be able to see it at shorter wavelengths as well. So if the fire is very, very, very hot, we will be able to see it in the 1.6 channel and also in the 2.2. So this is basically how we can observe the hotness of the fire. And for last, if we move towards the east to the Pacific, I'm pretty sure everybody has heard of Typhoon Sinlaku, which developed in the beginning of April. Here we can see 5 days loop of Typhoon Sinlaku, how it's seen with the Himawari 9. So this is during the true color image, and during night, you can see basically an infrared image where the the higher clouds are, or the higher clouds are white and the lower clouds are bluish. This is called the geocolor image. This look was created by Sira, but I think it's very striking to see that this super typhoon, which was a category 5 typhoon and caused a lot of damage in this area. And basically why it's interesting and why I show this, because there is one satellite, one low orbit satellite, EarthScare, which was also able to see this typhoon. So EarthScare is designed to measure how the cloud and aerosol affects Earth's radiation balance. So EarthScare is a joint effort by ESA and JAXA, the European and the Japanese space agencies. And why it's very interesting for us, because it carries the first cloud radar in space with Doppler capability, the cloud profiling radar, CPR. So basically this is an active sensor. So it emits microwave radiation at 96 gigahertz frequency. And then this radiation is getting reflected back to the satellite from the different particles. So basically, we are able to see inside the cloud with this instrument. So at 13 April, EarthScare was passing by or passing over Typhoon Sinlaku. This green line shows the EarthScare overpass. So basically, it was not just passing through, but it was passing through the eye of the hurricane or of the typhoon. So we can see what this typhoon are looking through in the vertical. So this is what we can see in this vertical profile. So we can basically see the eye of the hurricane, and we can typhoon, sorry, and we can also see the structure, how it is in the vertical. If we just zoom into the eye, then we can see also that how everything drops in the eye. So I think this is very, very nice, and it's not something we can see every day. So I thought it would be good to include it in the weather briefing this time. So with that, yes, there is a very nice imagery portal of EarthScare, which I put a link in here, because you can look at even, I think, near real time what EarthScare can see, and also you can go back in time and look at these images. So with that, I thank you very much, and if you have any questions, I'm happy to answer.